Welcome back, everyone. And in today's video, we're going to do a follow-up of episode 70, where we did simple texture generations with noise. There's a comment that I kind of really want to address. That he kind of mentioned that I did something wrong because the noise values I used absolute function on it, so I can then use the negative, because Perlin noise in general usually creates value between -1 and 1. So, but when you want to visualize it in color, the negative side you can't see. So I used absolute values so I can just quickly and get those values into the positive range so I can actually visually see them. Now he said I did it incorrectly, and in a sense he's right. I did it incorrectly in the sense that you lose the overall ups and downs of Perlin noise. So if you look at, like, he set up a nice example to prove his point, and it's he's correct in certain ways. We can pretend that this sine wave is Perlin noise, and by applying absolute value, let me get rid of the sine wave, I end up creating a bounce. So this is not the exact representation of Perlin noise. What I should have done really is to shift it. Let me do the sine wave again. So the idea is to try to bring the entire wavelength into the positive zone. Now the thing is, in the process you are actually changing Perlin noise as well. Even though you keep the wavelength, you are sacrificing amplitude. So the amplitude has changed. So the overall wave is a bit different. But at least you get the ups and downs of the Perlin noise wave. So he's correct in the sense that you don't see Perlin noise the way it's intended to. But that's okay, because you can do a lot of things. And that's why I say he's kind of right, because it really depends on the effect you're trying to do. So this is where we kind of left off. This is me doing absolute value. This is what a texture looks like as an absolute value, with no modification, no whatsoever. If I were to do a shift, so this way you can see the wavelength of Perlin noise, this is what it looks like. It's more blurry. The overall shape is still there, but it's more blurry. So let's say if I want to do this, like this, where here's the overall shape that you actually see. But now if I use absolute value, this is shifting. This is keeping the wavelength for the most part, the ups and downs. If I go back to using absolute value, instead of using Perlin noise as it's intended, this is what we see. So this looks kind of messed up. But if I were to do what I did, was increase the amplitude, then we have this effect. Now this is kind of hard to generate with the actual Perlin noise with shifting. So if I'm going back to shifting, I can't do 5 because the amplitude is too high at that point. It becomes pure white. So if I want to change it, I'm going to have to change the amplitude, or scale it, I should say. Maybe 1.2. Not exactly sure. I haven't really played with this. So we're going to see what comes out. And I think we might have to, since the wavelength is higher, we might have to do maybe at 8. Maybe lower. Let's try 3. So yeah, it's kind of hard to get that texture. I'm sure you can if you play around with more numbers, but that's why I kind of said it. Absolute or shifting is not necessarily incorrect. It really depends on what you're trying to do. So let's say if I go back here, I got this texture. This is like we can use this to create a cave. This could be a height map to create caves. So I might have explained it incorrectly in the previous video where he says, "Well, this is correct," but either way is fine. It depends on what you're trying to do with it. So you can be trying. I always suggest, like I've tried to go through in the last video, is that you should try everything. You should really experiment. You should try every little thing. Don't do things the correct way, because sometimes doing things the incorrect way will sometimes give you happy accidents that you didn't expect. Like this, if I was like, let's say if I was a normal person, it's like I know I have to keep hurling noise and do this, I would have missed out on seeing this texture because I went the way of doing it the correct way, as opposed to just experiment and see what happens. So I just quickly say, you know what, the quick solution is absolute. This way I get the negative back. I get the negative into the positive aspect of the chart, or of the positive realm. Now, to keep that in mind, when we're dealing with Perlin noise and everything else, these are just wavelengths. So if I'm doing absolute and I'm actually changing the wavelength, so it's more of a bounce, right? You can do a lot more than that. So let's say we have, let me just get rid of amplitude. We have other timing functions that we can use that generates different types of waveforms. So we have all our easing functions. So let's say I take Perlin noise, I do an absolute value of it, and I apply an easing out on it. And what happens? It makes things a little thinner. And I make everything thinner without actually adding an amplitude to it. So a little extra gets me a long way. What does it look like if I were to just shift the wavelength? Still white. But I probably need to lower the value maybe. Maybe 0.6. Get 60% of the wavelength. Still nothing. Wow. About 2? Wow. I guess shifting is not the best way sometimes. Wow, I can't get that any value coming out. Let me try 7. Wow. So yeah, absolutely. By its experimentation wise, it seems like you get more out of it if you were to do that. All right, so let's try other easing functions. See how we can get this thing working just better. This is what it looks like when we apply absolute. Let's try what shifting looks like. Refresh. Similar, but different. This might look pretty good in an animation. Like I said, you get different effects. You don't know. What happens if I apply an amplitude to it? Goes higher. Let's try 2%. Refresh. Oh, too much. 4%. Still too much. 7 was good. Let me try 9. So yeah, I think overall better off using absolute. What do I get here? You get more shapes. Let's try one more. Let's try different type of easing, see what happens. Let's try it without amplitude. I probably really should show without this too. Maybe that's part of the problem. Now that's pretty neat looking. So by using circle out, let's see what circle out looks like when I just use shifting. It's more cloudy. Let's try some of the easing functions without that that splitter. So what this looks like using shifting. So that's a neat effect. That probably would have seen. So this is shifting and then using a bouncing out easing generates something like this, and then you can sit here and play with it a little bit. Let's try easing out. It's more whitish. But yeah, again, you can play around with this. Figure out where that dark spot is. Like what's the value around these dark spots. And you can probably shift things around. Let's see if I do that. That's probably not going to work. No. Let's see. That looked really gray. So maybe 0.2. Refresh. Nope. 0.1. Actually, you know what? That thing was really gray. So it really should be up in the nines. So being more the other end is no. Man. About 8. There we go. So you gotta play with the numbers. So this is kind of a different effect, and this is what shifting using elastic out. Again, this looks pretty cool. I like this. This might be good if we change the frequency and the amplitude. This might be kind of good too. I kind of like how it kind of puts that inside type of thing. Let's try the other ones because now that we got the thing just right a little bit. Let's see what some of the other ones that didn't just do good. There's another one. This is a cool little effect. All right, that's neat. Like again, this is using shifting, bouncing, and then applying a different way to kind of divide the colors. And let's try circle. Let's see what that looks like. Refresh. That's just dots. So, in the end, with all these experimentations, I just want to really show you that either way, you're going to get different results. And a wavelength is a wavelength, and you can change the wavelength anything you want. The whole auto-generated textures all based on some kind of algorithm or some kind of wavelength that you're manipulating. So Absolute actually makes it easier to manipulate this Perlin noise, but you can still use the shifting and get different results. You'll get completely different results, and playing with the numbers, you have to play them with differently. So you have to experiment and try it out. That's what I said. With this time around, we started adding easing into it. So we take Perlin noise, we take that and we feed it into an easing function and see what we change the waveform even further. So you can compound wavelengths and modify them and twist them around, and you can see what kind of results you get. There's like tons of easing functions you could experiment. Yeah, you can just use easing functions themselves instead of using Perlin noise. You just need a way to go from 0 to 1 to get out the output, and then you get the wavelength value of that, and then you can apply that any way you want. So, like I said, you can do anything you want, and that's the whole point, is really to experiment, try different methods. Like here, I wanted to show you absolute and then the shifting, and you get different results. We did manage to find a couple cool textures once we start throwing them into the easing function to kind of manipulate the wavelength a little bit, and then changing this value so we can actually see the results a lot better. Like I said, just experiment. That's really the driving thing I want to especially when it comes to texture generation. Experiment. Try everything. Find any kind of mathematical wavelength timing kind of function and throw it in there and see what kind of results you can do. Play around with the numbers, mix and match different things and see what the end results are. That's really the gist of it. That's really it. So this is really just this video is just really just kind of a continuation or a follow-up. So I just really kind of just talk about the topic that he brought up. And like I said, he's right in the sense that absolute changes the Perlin noise. But that's okay. Like I said, it depends on what kind of effect you're trying to do, or if you're experimenting and seeing what results you get out of it. So that's what I really want you guys to know. Just experiment. Don't think about what's the correct way of doing it. Just play with it because it's fun, and it's fun to find things. I like playing RPG games, so and I love loot drops. So to me, it's like I'm playing this mathematical RPG game, and every once in a while, I get a really cool loot that gets dropped. So if in gaming terms, that's how you can think about this when you're playing. You're playing a game. You're just experimenting. You're trying things out, and you're seeing what the results are. And you might just get this legendary texture that's like perfect, something you don't even expect that you wanted to use for your game. Like I said, I when I first experimenting, I managed to find something that I can actually use to create height maps that creates kind of this maze-like world. So, like I said, that to me was a happy accident because I used absolute value as opposed to using the correct way, just shifting the thing. So, like I said, experiment and have fun, and you might find happy accidents. So, that'd be all for now. Please like and subscribe because of the new YouTube rules. I need subscriptions up to like 1,000. Else, I'm going to lose a whole mess of YouTube features like creating thumbnails, which kind of sucks. I'm going to lose that ability because I don't have enough subscribers because of certain people are ruining for the rest of us. So, like I said, just give me some subscriptions so I can keep some YouTube features that I've come accustomed to using, like thumbnails. All right, see you guys at the next video.